open your mind or leave or just, I don't know what. Meeting recording is in progress. Okay, super. So as apparently is typical in OHDSI, I have taken a roll call, and if you don't see your name in the roll call on the Word document, then say something. Otherwise, for folks who have never been to the Hadoop Working Group meeting, if you could spend less than 1 minute saying your name, and if you want the organization that you work for or associated with or nothing, or say like what is interesting to you, that would be super. And anyone can start.
Hey Sean, this is Vartika here. I'm joining for the first time.
Oh, Vartika, she's from Cloudera. How are you today?
I'm doing well, thank you. Sorry for joining late.
Oh, no problem.
Hey, Sean.
So you're new, Vartika. Do you want to start, and then whoever else was volunteering, just less than 1 minute, who you are, where you work, or what you like to learn?
Yeah, sure. So I'm Vartika Singh. I'm based out of West Coast in US in professional services team. I did a little bit of work on a genetics-based project at Seattle Children's Research. Since then, I've been interested in getting involved a bit more, time permitted, and Sean and Tom have been nice enough to give me a little bit of background and introduction. So, yeah, I would like to be more involved. Thank you.
Thank you.
Hey, Sean, this is Jason Poovey from Georgia Tech. This is my first time joining as well. I work at the Georgia Tech Research Institute, and I lead a group that does high-performance computing and data analytics. I'm also working with John Duke on building out our health data analytics platform here at Georgia Tech. And I'm also working with Sean here on the Precision Medicine Initiative with Cloudera. So we're very interested on many fronts with analytics and Hadoop and all of the benefits that we can get from that.
Welcome. Who else is here for the first time?
This is Karina, and I'm here for the first time. I'm from Amgen. I'm a senior programming manager there. And we've had Hadoop and Impala for about 1 year and 4 months now. We were initially trained by you folks at Cloudera, and we've been using Hadoop to store the OMOP common data model and use that system alongside the common data model to do many of our queries off of some of the larger data sets, such as MarketScan and Optum.
Welcome.
And thanks. And I'm here just to find out what's going on and hopefully get more involved.
Super. Who else is new?
So let me start here. I'm Mark. So I'm joining this the first time this meeting. So I'm working for Lund Health. I'm located here in San Francisco, and I'm leading basically the effort in Lund Health related to analytics, outcome analytics.
Do you have some Hadoop, Volkmar? I heard 2 weeks ago that maybe the NIH has some Hadoop.
Yeah, we do. We have deployed in our environment a few clusters for development and also for UAT environments to work with patient data, right? And yes, we do. We have a Cloudera cluster deployed.
Oh, wow. Okay, super. Who else is new? Someone named Greg is on here. I don't know Greg, I don't think.
I'm sorry, it's actually Greg Lebanon from Odysseus. I was a couple of minutes late. Sorry about that.
Oh, Greg from Odysseus, okay. Do you want to say one minute or less, Greg, about yourself, to introduce yourself?
Sure. It's not the first time I'm here, but again, I'm Greg Lebanon from Odysseus Data Services, and we specialize in real-world analytics solutions. With I guess one of the contributors into OHDSI community. We manage vocabularies and provide support for different tools, including Athena, and lately getting involved in working with Apple, so it's quite evident.
Super. Okay. Any last new people that want to go, so we're not too far behind? I'm going to try to keep it moving.
This is Chris Wallace.
Okay. Oh. Good, Chris. Hi.
I'm from Quintiles IMS in Pennsylvania.
And what's your life story in 10 seconds?
We've just started using Hadoop to transfer some large data sets into our OMOP.
Super. Okay. It's great to have everyone here. Today, as you probably know, we have a demo from Outcomes Insights. Before we start that, we have 5 minutes left for old business, and I put this agenda yesterday or the day before on the forum. So the first one is testing. If you haven't heard, Tom White has been continuing to create new code, which is super. And Tom would like to have some folks sign up or volunteer to run some Achilles against the Impala CDM code that has been committed. So Tom, are you comfortable spending 2 minutes on being specific about what some of these many folks on the phone who have stood up Hadoop could do?
Yeah, of course. So I've done a bit of work to get Achilles working against data that's stored in Hadoop. So I've managed to get that working, but it would be great if anyone who's got a Hadoop cluster and is interested in OMOP would like to try running this code to see if it works in your environment, basically. So any kind of volunteers or people who are interested in talking about it more, it'd be great to discuss that more on the forum and take it from there, really.
Any questions on that? Any volunteers who will have my undying love?
Yeah, this is Key from Quintiles IMS. Yeah, I think we are interested in giving a shot at running the Achilles report in our group.
That was Key Wang.
Yes.
Great. 3 cheers for Key.
All right.
Thank you. Anything
Thanks, Key.
Tom and I can do within reason, we're here to help you. Who else?
Sure.
Anyone else willing to be put on the spot? Okay, let's retreat and declare victory. That's success. Thank you, Key. Just know that I think Tom is pretty sure this is the next step. Also on old business, Tom has done a bunch of work in SQL render. Tom, do you want to describe that in 1 to 2 minutes? Just because it's so impressive, to be honest. I thought it would take 2 or 3 years to do.
Yeah, SQL render is a R package which takes a standard form of SQL and turns it into a particular dialect for a particular database. So it has Oracle, Postgres, and other databases. And I've added support for Impala, so it will convert the standard SQL that's used in Achilles, for example, and will allow it to run on Impala. So, but I think, Sean, you want to talk about SQL Render 2, which is something else.
Yeah, I don't know. I don't know if I'd call that old business. If anyone on the phone wants to talk about SQL Render 2.0, it's above my knowledge grade, to be honest.
Hey, Sean, I can comment on that. There's an active thread going on the forum that this is Jason Bowie, by the way, that's going back and forth on SQL Render 2 that I would just reference this to. We're debating, and it would be good if anybody's interested in that to hop in the discussion about whether SQL Render 2 even makes sense. And also, Tom, that sounds really great too, about getting Impala working. I'll check that out.
Thank you.
So SQL Render 2.0 would be a new version of the SQL Render parser that hopefully will have an Impala capability as long as we keep it up. Okay.
The discussion is centered on SQL Render now uses MS SQL Server as like the starting dialect. We're discussing whether we should have sort of a more ANSI SQL starting point that would be more translatable, and also how do we handle the fact that if you write something generically, it's not going to be performant because you can't take advantage of the performance aspects of each individual dialect. So how do you handle that? Do we actually write our own parser? You know, that's where the discussion is going, is maybe rethinking the core structure.
Got it. Okay. Any new, so we can get to the outcomes insight in 1 minute. Are there any new or grave requests for Hadoop capabilities in the near term for OHDSI tools? Okay. Once we're done with this concert series of demos, we'll have more time to delve into these things, so I appreciate your patience. Okay. With that, let me say one thing. It has been so great. This community has pushed me. I know if you guys had not asked to see what other people are doing, there is no way that I would have spent the time to go out and cajole and try to get people to show stuff. And as a result of that, it's been great that so many people have signed up, and Outcomes Insights is great because they were willing to actually be first, which is always hard. So with that, I am going to stop sharing this, and I think we're still recording, and I was going to make someone presenter, but they did it themselves. Eee, super. Can some people say that they can see Mark Denise's screen now?
Yes.
Is
okay,
it big enough?
Is there anyone who?
Can you see it?
It's big enough for me, but I don't know. Is it too small for anyone? Okay.
Too big?
No, it's not. So yeah, by minute 45 or 47, Mark, I'm going to pull out the hook, so I'll be quiet.
And I'll try and go quickly. Those of you who have heard me speak before, you know that I'll do my best. I may fail. So please pull out the hook. Do not be shy. My name is Mark Denise with a company called Outcomes Insights. Some other people on the call, Michelle Gleason, Jennifer Durier are also with us. We've got Ryan Durier in the room with me. Just 10-second background on us. We actually started as a company that analyzes observational data and does a few other things as well. And this project started over 3 years ago in our internal efforts to optimize the way we analyze data. Particularly at the time, we were focused on SEER, Medicare, and linked data, and then it's grown from there. And then we got involved with OHDSI because of the common data model, which saved us at that time the effort of trying to figure out how to build our own common data model. So, and I should also mention that during the demo part, we're working in collaboration with Amgen, and Karina, who's also on the phone, has seen a lot of this stuff before. And we also are working with the National Cancer Institute on some of this stuff. So, but please feel free to stop me or ask questions, and people on my team, if I say something wrong or egregiously incorrect, just also jump in. So, what is Jigsaw? Why are we here? Our goal is for Jigsaw. Jigsaw is a saw, right, used in woodworking to cut precise pieces. So our goal here, that's the name. The goal here is to query observational data sets and extract data for a specific study design. So this is not an analytic tool, although in the future we will be adding analytic pieces. This is about cutting the data. When we designed it, our goals were, number one goal was flexibility. So the first task that we undertook was to write declarative language to unambiguously define queries in a way that's independent of any particular database system. So you could, this is our version of SQL Render, right? This is our solution to the same problem that SQL Render is addressing, just to give you an idea of what that's about. We wanted to be able to generate SQL-based queries for a variety of databases, including Impala. And then we also want to be able to support different data models. Obviously, OMOP, we've worked on our own in the background, and in the future there will probably be other data models, or certainly there's different versions of OMOP. So we wanted to design the system so that we could work across different data models if the opportunity presented itself. We wanted to make sure that we provided consistent results, as well as a consistent interface for designing and implementing studies. And we wanted to make sure that people could conduct research faster, which doesn't necessarily mean that queries run faster. It's a different animal. So by that, I'll explain what I mean by that in a second. So here's just a 30,000-foot view of what we're doing. And again, I'll do a demo in a few minutes to walk you through these different components. But what we start, so Jigsaw is up here in the yellow pieces. The three main components are listed here. So we have an observational study builder. So this is where you actually design an observational study, where you select patients, you decide things about look-back periods, inclusion-exclusion criteria, baseline variables, outcomes, and censoring. All of that's handled here. In order to build the study, of course, you need to study something: diabetes, heart attacks, drug use. So in order to do that, the study builder relies on algorithm repository. So the Jigsaw algorithm repository stores inside of it all of the clinical events that people might want to study. And of course, if you want to create a new clinical event, you need to be able to do that. So we have an algorithm maker, which is way over here, that allows you to use the conceptual language, which I'll talk about a little more, to create an algorithm. And I'll define a little bit in more detail what I mean by an algorithm as well. So you can put that in the jar and use it in the job. So I'll try and use observational study builder, algorithm repository, and algorithm maker, but if I slip into our internal jargon, job, jar, and jam, you'll at least have some idea of what I'm talking about. And the way this all works is the observational study builder, the back end behind the scenes, generates a whole lot of SQL queries that are passed through to the Hadoop cluster using Impala. And so they can be applied to any of the databases that might be in the Hadoop cluster. I've just listed a handful here. Some companies have 20, 30 databases. The queries operate on a database, and then the data is cut, and the output still sits in the Hadoop cluster, and there's a number of data sets. We generate a variety of tables for a particular study, and these are all placed in different, for lack of a better word, folders. They're schemas within Hadoop. So this study here will have one record per person file, multiple records per person file. It's got metadata and data dictionaries all within study 1, and study 2, which will be a different study, will have its own set of these, and so they're available for then analysts to use. So that's the 30,000-foot view of how Jigsaw is working. And I'll go through in a little bit more detail, because I know this work group is obviously focused on Hadoop, and I'll show you how we tie in with that and why it's important. So I said we do studies faster, but I didn't exactly say how. And so this is the design philosophy here, and this is where Hadoop comes in very handy, because it is very fast. The way the world usually works when you're doing a study using observational data is there's time spent to design a protocol. That doesn't change. You still have to figure out what the research question is and plan the statistical analyses and all of that. In between here, and then at some point you have to actually analyze the data. Your Cox proportional hazards model or whatever statistical analyses could be something very simple. But in between here, someone's got to go into the Medicare, Truven, whatever data set and cut down, that very large data into these relatively small data set that's relevant for the study. And as many of you know, that's done by writing code, often in SAS, R, or Stata. There's certainly lots of other statistical software out there, but it involves, particularly at the enterprise level, writing code, debugging code, identifying problems, issues, resolving them. Then there's a whole QC process. And while it's not 4 to 8 weeks of continuous work, the process of doing this and communicating and everything, in our experience, a typical study takes 4 to 8 weeks. Certainly there's easier and harder studies out there. So this is, this is a typical kind of situation. And what Jigsaw is intended to do is to take this process, and allow you to do it in, depending on the compute time here and the size of the data, less than a few hours to get to the same place. So for what we're doing is you have to actually have the algorithms for the clinical events that you're interested in for the study. Again, diabetes, statin use, whatever it is you're studying. You actually have to create the study in the study builder that I talked about. It's helpful then to review all of that to make sure that it's right. And then there's the compute time where we pass this on to the back-end database, which in the case of Hadoop would be via Impala. And the compute time will vary if you're working on market scan and it's 5 or 6 terabytes and you're doing a very complicated study, it might be 3 days. If you're doing smaller things like with your Medicare data, we get stuff back in 30 minutes to an hour. Really depends. But that's the philosophy. So I'm not making claims about that this must be 4 to 8 weeks and this must be less than a day, but just philosophically, that's the kind of time we're trying to save. So let's talk a little bit about how this all works. And in order to do that, I want to just be very precise about some of the terminology we're using, because I've said algorithm, but that probably means different things to different people. And so I'll be a little more precise about algorithms and how they fit into studies in the way we view the world. So almost every study that I can think of begins with a code set. You need, because we're working with electronic healthcare data, we need a set of codes. And by codes, I mean ICD-9 codes, SNOMED codes, DRG codes, NDC codes, something that is in a database that indicates that something happened. So we need at least a code to identify people or events of interest. And here's an example for diabetes, ICD-9 250.x. There's a lot. It's more than one code. It's a set of codes. That would be a code set that identifies diabetes. Now there's the idea of an algorithm. Now, a code set is an algorithm. It's the simplest kind of algorithm. But an algorithm may include a code set, possibly with temporal or other selection logic. So it may not just be sufficient to say 250.xx. You may want to say, I want a diabetes code that I see 1 time in an inpatient setting or 2 times in an outpatient setting, at least 30 days apart and within 365 days. Okay, wow, that's a more complicated query. Philosophically, it's the same thing. It's diabetes, but it's more precise and perhaps has a better sensitivity and specificity, meaning that it more accurately identifies patients with diabetes. Then we may use an algorithm or a set of algorithms to identify a cohort. Now, these are the people that we want to study. So we may actually have 3 algorithms, one for diagnosis codes, one for medications, and one for laboratories like HbA1c or fasting glucose. And we may also have other inclusion criteria. So a cohort is actually a set of algorithms that define a person, not just define a person, but to define a person in time so that we can identify them at a specific point in time. Once we can do that, then we can design the rest of the study, which includes not only the people, but also baseline variables as well as outcome variables. And then we also have to generate, as I said before, 1 record per patient, multiple records per patient. The reason for that is people may have many prescriptions or many lab values, and rather than make this cohort file extremely wide, it's obviously much better to make it tall. Data dictionary and then study metadata. In fact, we output the entire study as it's specified as part of our output file. So so when I say study builder, and there's lots of, OHDSI and lots of organizations are doing this, and human beings are doing it, as I pointed out by hand, I just wanted to be a little bit precise about exactly what's going on and what we're trying to do. And you can see from an Impala perspective that we are generating many, many queries, and we are organizing them in a very particular way so that we can design all of these files and they have the right information in it. So how do we do that? Right, okay, it's great, I can sit here and wave my hands, and particularly since I'm not a programmer, that's about as far as I can go, and I've got Ryan here who will be able to answer more specific questions since he's the architect of all this. We designed something called ConceptQL. Ryan designed this. This is his idea, and we've been using it for several years. It is a way to represent a query unambiguously. It's stored as a JSON object, not SQL, and I'll show you that in a second. It allows for as much complexity as you can probably throw at it, and it's open source. So on our GitHub repo, you can see the ConceptQL repository, and there's documents, like an 80-page, I don't know how many page document on there describing all the functions and things like that.
A lot of pictures.
A lot of pictures, yeah. A lot of it's not so much text as pictures. The way we accomplish this is so a lot of this is in Ruby, and we use the SQL library in Ruby, which allows us to take a JSON object and generate ANSI standard SQL for a specific database, whichever one. And it's possible to write. For Impala, was there one when we started? It was kind of, no. So we had to start from scratch and write our own adapter for Impala. So now that exists, and that's open source, right? Yeah, that's available. So if other people want to use it, they can. It's SQL only. It does not use as before there was a discussion about SQL render and using database-specific, faster code. We don't do that. It's syntactically correct. It is not, as was mentioned before, optimized for speed. That's hard to do. And from our perspective, at least where we are in development right now, we're pushing that job to the query planner and the database system, hence Hadoop. And Impala is our best friend right now because that it's possible to scale it out and solve some of these problems with hardware rather than software. But there's always, that's not to say that there aren't things that we can do to optimize, and it's just, no, we've been focusing on making things work and adding features a little bit more than, taking things from 3 hours to 2 hours. So how do we represent, so in order to pass these queries in, we need to do two things. One is we need to allow human beings to say what they want to say and describe what they would like from the data. And then we need to store that as a JSON object so that ConceptQL can actually then generate the SQL that will accomplish the task. And so this is a picture of a rather nonsensical algorithm, but I just want to walk you through this real quick just to get an idea of what's going on. So this, and I'll show you this if we have time. This is something that is a drag and drop interface to create something like this. So the way to read this algorithm is, we read it left to right, top down. This is a selection operator which selects ICD-9 codes for hypertension. This is a selection operator which selects ICD-9 codes for myocardial infarction. This is an operator that allows us to make temporal comparisons. So we want hypertension after myocardial infarction. So this is actually not part of the data. This is just used for This is used as a way to select hypertension codes that are relevant. That is, hypertension codes that come after an MI. And then this is another, it's a filter, which allows us to then take the first. So the way you read this is take the first, find all hypertension codes, take only those that come after an MI code, and then take the first. And then this is stored as this JSON object over here on the right. You can see the codes are there, and those of you who are adept with JSON can probably read this, but it's just a nested version that's more easily read, in my opinion, by humans looking at graphs like this. Does that make sense? Okay. So the one thing I want to get to, this is a study here. There's lots of things to accommodate in a study. Look-back periods, blackout periods, censoring, follow-up, baseline exposures, follow-up exposures, start of observation, end of observation. This is all part of the study builder, and I'll show you that. But this is what makes the queries complex, which leads to our, what do we have here, 8, and there's probably more, 8 things that we ran into in terms, this is not limitations, or we would have this no matter what database backend we were working with. But obviously this is the Cloudera working group, so we thought we would share some of the things that we learned in trying to implement this system on the platform. So as I mentioned, we needed to put our own adapter for Impala. We're using a driver, which is passing all of this back and forth between our application and Impala. We're using Impala Ruby, which is not supported by Cloudera, but we may move to the JDBC driver. There's a lot of work on authentication and impersonation related to Kerberos. Ryan can spend days talking about some of that stuff. But that, in terms of system integration, it took a lot of time. I couldn't boil it down into a single bullet point other than to say there's a lot of work there. As many of you know, there's a lot of differences related to SQL syntax, so date time, no temp table, so we're using common table expressions. Limits on in for large code sets, no intercept, except operator. So the adapter works around many of these things. Many queries failed to run early on, so we changed a lot of our unions to union alls. They worked much, much faster, and we avoid group by where possible. We can use mem limit. Again, some of these we're talking about 5 terabyte data sets and doing a lot of things by person. So the query planner wasn't so great early on, so we forced a memory limit on and then got the queries to complete. And then in 2.6, things seem to be a lot better. So we would, 2.6, Impala 2.6 is much faster and substantial reductions in memory use. So we encourage people to stay on the cutting edge, and again, things work faster here. And then runtime filter, in the way we're constructing queries, we ended up with some non-deterministic behavior, so we turned that off, but that's something else that could speed things up as well. So I'll switch over to the demo unless somebody's got specific questions they want that aren't very clear. So this is the application. We've got 3 sections to it. One, I'm kind of jumped into the middle. I'm jumped over the landing page to take you to the algorithm repository. But you can get to the 3 main components, which is the algorithm repository, the study list, and then exports. The algorithms you can see here is just I've got 205. This is a working version for internal use and testing. So what's nice is that these are the algorithms that select things. So if I want to search for diabetes, I can do that. And if I hit enter, there we go. Gotta wake things up. I guess I waited too long. Sorry about that. There we go. Okay, so there's the landing page. We can go to algorithms. If we want to search for diabetes, we can do that. And fine, we've got lots of there's a lot of test and draft things in here. The main, so this is when I say an algorithm, I can click on something like, actually, you know what, let me do statins. So we've got a little bit of metadata about an algorithm. This is the simplest possible algorithm. It's just a code set here. And, it's got 1,184 codes, so I'm not going to show them all, but they can be exported or imported. More complicated algorithms for things like acute pancreatitis involve ICD-9 codes and CPT codes where we union them together and we take them, based on their provenance as an inpatient, from an inpatient setting. Again, metadata, things like that. What's nice about this is you can take a look at it, and after you get the hang of reading them, you have an idea of what the algorithm is actually doing. So it's nice when you're building a study because you have access to this library and you can see all of these things. So let me walk you through a little bit about what a study is. There we go. So here's a list of all of the studies. Again, this is our test database, so we've got lots and lots of studies in here that we built for test purposes to make sure things are working properly. I created a simple study for the Impala Working Group, or Hadoop Working Group. I've got Impala on the brain. The way we design a study, and I got about 5 minutes left, so I'll make sure I finish at 8:45 local time here. We have different sections, and you can navigate through a study over here. So let me just sort of introduce you to the left side. These are the different parts of the study over here, and we can navigate through them by clicking, or you can scroll. Sure.
Mark, you can go till 10 of. It's fine. I don't want you to. Yeah. You can go long. It's okay.
Okay. I'll do my best. We've got people over here telling me how many minutes I've got. It's fine. They know how long I can talk. So we've got over here sort of the big picture of what the study has in it. We have the ability actually to, in real time, do counts at each step in the process. We've turned that off because we've been working at some very large databases, and as fast as Impala and Cloudera is, when you're working against 5 terabytes of data, it's just not a second or two to do this stuff. Against smaller databases, what we often do is actually take random samples of about 5 or maybe 10,000 people and for each database to give you approximate numbers over here, but we haven't re-implemented that yet. So the study can have a number of things that are study metadata itself, a title, a description, status, and a type. We've got a few things like a default study, and we're also working on incorporating some Sentinel kinds of analyses or studies in here. That's still early days on that. The index date is, as I mentioned before, is the key part of the study. You think about this is really how your cohort is defined. In this case, this is a study of patients with diabetes. So the way I do that, you can see here in this box, the index date is based on diabetes. And what that means is we find the first instance of diabetes recorded for a patient, and that defines their index date. So the question is, how did I get these boxes to appear here? Well, what I did was initially it started off with no boxes, and it had that blue box that said click to add a new event, which takes me to the algorithm repository that I showed you previously. And again, if I had wanted to do a study of statin users, I would have, and I'll just do it for purpose, I would have done the search that I showed you a few minutes ago and pulled these algorithms and maybe looked at them to see whether they were the ones I liked. And eventually I would have said, I really like this one, because I actually went to the OHDSI webpage and I downloaded from Athena, is that the tool? I downloaded the code set for all of the statins, and so that's what I wanted to use. So I'm going to use that, and now you can see that I've brought that algorithm in. So what this would do now is it's going to look for the first occurrence of anything that I put in here. So if someone got a statin prescription before they were diagnosed with diabetes, that would mark their index date and the beginning, and it would separate sort of the baseline period from the follow-up period. But I'm not going to do that. So I just delete it. So this defines the time horizon for the study. This is a smaller version of what I showed you on the slides, where we can set a look-back period, which is a requirement. Here I'm requiring that everybody has at least 6 months of observation time before their index date. I can set a maximum too if I want. So I'm only looking in that 6-month period. I would set this as 6 months too, but I'm not doing that. We can set out blackout periods, which for outcomes prevent us from seeing events that occur a particular duration of time after the index date. We can set minimum follow-up periods and maximum follow-up periods. When we get down here, we talk about inclusion criteria, first in terms of population characteristics, age, gender. We also have, if we want to do, I should also mention for any epidemiologists on the phone that right now I'm thinking in the context of an incident cohort study, but we can do prevalent cohort studies, and we have a new version of the UI coming out in, I don't know, 2 months that will handle this more gracefully, but this section down here is for, it helps us do some of that. For the most part, you don't need to worry about this. Inclusion criteria, so I'm also, not only do they have to have diabetes, but I'm only taking the subset of patients who also have hypertension. Again, I'm using CCS codes for this. I could set a maximum look-back period. Maybe I want to set, I only want people with, I want to make sure that it's diabetes only within the 30 days before whatever qualifies, the diabetes diagnosis that qualifies them for the study. So I could set this to say 30 days, and so it would only look in that 30-day period. Prior to, for hypertension, it would look for hypertension in a 30-day period prior to the first diabetes diagnosis. I can exclude people here. I'm excluding people who have a history of myocardial infarction, and I may want to know, again, whether they're taking statins at the time, so it's not selecting people, it's just more information that I need to do my study. Censoring, we always censor at death, although technically you can delete that. And I want to look at time to first myocardial infarction, so this is going to pull out all MI events as an outcome. So now I've designed a study to take people with diabetes and hypertension, exclude those people who have an MI at baseline, and then find and figure out how long it takes them to have an MI from the time they were diagnosed with diabetes. So that's my study, and I can save that. I already have, and I could export it. Export saves and exports, and there we go. And this allows me to choose data sets. We only have the synthetic public use file here. I can truncate the dates. I may want to, if I've got 20-year data set, I may want to only look at the last 10 years of data, so I can set those things here. I can pick a folder to output my files to. I'm not going to do that because I've already done it in the interest of time. And so here's the actual export page. So these are all the exports we've done. This is the one I did for this demo. I did it last night. It tells me when it finished. I don't need to run it again. I can delete it if I want. And then we've got a little viewer here, which is really handy because it sort of gives us an idea of what it is that we're outputting. So here's the export information. Here's the folder it was sent to. Here's the data source we're using, the date ranges that, that the data set has, or shorter ones if we decided to truncate it manually, that it's finished, how long it took to do. It took 2 minutes, 250 patients. It should take too long. Here's the cohort file. So again, this is a small database, so this is the information that's in the cohort file. It goes to the right a little bit farther, but we've got 1 record per person, we've got age, et cetera. We've got information about the diabetes algorithms in here and their dates. We've got a data dictionary which describes all of that information based on the study builder that we've filled out. We've got all of the outcomes, which shows potentially multiple events per person, so people may have multiple diabetes codes, and they'll be in here, and we've got a data dictionary for that. And then one of the other things, which hopefully did not crash while I was, this is what it looks like in looking at it in Hadoop with 1 minute. Oh, I'm just about done here. This is actually how it looks if you want to look at it via Hue. You can see these same tables here. And one of the other things that we've got in here is the actual queries themselves. So we output the query. Not only do we output the study, so the metadata, which is that study that I showed you built in the job, all that is a big JSON object that's spit out. But the individual queries, you can see we drop tables to make sure that we're working with a clean slate. And then here's all the queries that you can't see all the text, it's all one line per, but here are all the queries that were executed. And did I miss anything that people are dying to ask about? I think I've got. And that's everything I wanted to get through. So I got 10. It's 10 of. I don't need the hook. So happy to answer questions.
Absolutely stunning. Thank you. And we maybe can do 5 minutes of questions. So do folks want to just speak out?
I have a quick question. This is Jason from Georgia Tech. This looks like it's very much an alternative to OHDSI. How do you link with the OHDSI tools at all, or do you see it complementary at all between some of the tools they have?
I would say, yeah, that's actually how this kind of started out. Is we actually got involved with OHDSI because we'd already done. In 2014, we had a working version of this, so we've just kept going, and we're on, I guess, parallel tracks really. So I would say this is a complement. It depends on what you. Obviously, we're a commercial company, so we license this to large commercial organizations. So I would say it's probably a fair characterization that it's an alternative too. But we try and collaborate, and push stuff back and into the OHDSI community and make as much of our stuff open source as possible. So
the follow-up to that would be, it's interesting you've also tackled SQL Render. So I'd be interested in getting you involved in that discussion on SQL Render 2.0, because they're rethinking that, and it looks like you've already thought about many of those challenges.
Yeah, and the way we kind of avoided, what we didn't want to do was have people write SQL to do this. We needed to generate all these queries programmatically, and so it's a huge, and SQL Render is intended to leverage the large number of people who can actually write SQL and allow them to participate in this open source community. So, if the stuff that we've got out there can be helpful, obviously we would love to contribute. But I think it's hard. You can't. The only way to generate queries with Conceptual is with code and not with handwritten SQL. So the starting point is quite different, even though the end result is almost the same. Does that make sense?
Yes, thank you.
Hi, this is Aaron from Takeda. So, Benjamin, it looks like this could be a good tool for easily creating or adapting existing algorithms for derived or composite variables. For instance, you had MI as one there where you group several codes together, but you had to create a multiple cause cardiac mortality algorithm that had several ICDs, several temporalities, maybe CPT codes as well. This would be an easy way to package those together and then repeat its use across different cohort creations. Is that a fair characterization?
Yeah, that's it. And that's exactly, and one of the things we're going to work on this year is the idea of nested algorithms, so that you can actually create the individual algorithms, because some people may want an MI algorithm and some people may want a composite endpoint. So yeah, so
where I see this being helpful is you can rapidly build a cohort in an extract format that you could analyze with either Jigsaw or with the other OHDSI tools as well, whichever you preferred. But the creation of that initial cohort would be streamlined. Is that right?
Yeah, we have not. We've talked about it, and then we spent most of the last year integrating with Impala, but trying to get our stuff to be able to share cohorts with OHDSI. Yeah, that would be. I think it's possible. We have to kind of think about how we might do that.
No, the cohort table in OHDSI is a subset of the information that Conceptual extracts from a database when it's running its queries. So it is, in my, I haven't done it yet, but in my mind, it's a fairly trivial thing to generate that information and then populate the cohort table. We have not had any internal need or none of our clients have asked for that feature yet. So it's not something that we've spent any time pursuing.
But you're right, that would be a natural way to make things work well with the OHDSI tool stack, because you could have all kinds of pre-populated cohorts that way.
That's where my brain was going as well, so thank you.
Sure.
Thank you. Hey, Mark, can you either put on the screen or tell folks how they could contact you with further questions?
Oh, sure. Yeah, I guess. Probably didn't. Yeah, will we put these slides, do you want to make these slides available? And then I'll add them to, I'll just put my contact information on the back end.
Super. So to honor the time, are there any, so by the way, thank you. Very amazing, beautiful. I feel like I could know enough now from what you did to actually do a study. So on behalf of Human Health, I will not be doing that, but it looks intuitive. Any comments from last parting shots or comments from the audience? Okay, well, you have the information here on how to contact Mark. In 2 weeks, we have our next one. I can't recall who is showing, but we'll have another wonderful one. I will be probably by end of Monday, I will have this WebEx recording file transferred over to an MP4 file and uploaded on a private YouTube spot. And anything else? Okay, folks, Happy New Year. Have a great day. Great.
Thank you.
Thank you.
Thank you.
Okay.
Thank you.
Bye.
Bye.